am now recording, so you guys can share your computer, and I'll mute, and let's get things rolling.
Alrighty then. Right, Tim?
Okay. Good afternoon. We'll be talking about ABS today, but before we do that, make sure you subscribe to Sly McGee123 on YouTube. Okay, ABS piping by Philip Spiels and Timothy Gutierrez, DR180, taught by Mr. Ward. So the overview of ABS piping. What is ABS piping? What are the uses and other facts of ABS? What are the differences to ABS versus PVC piping? What are the pipe fittings of ABS? And what are the advantages and disadvantages of ABS piping?
So the first thing I'd like to talk about is exactly what is ABS piping. So ABS piping is very similar to PVC piping, being that it is mostly used to transfer liquids and other different kinds of liquids like sewage or just water, and it can be used in a controlled environment. So some uses and other facts about it is that ABS is highly used when removing waste or transferring liquids, and it is mostly suited for underground projects as it can wear and tear from sunlight. It can also be used as a protective cover around electrical wiring. It's very lightweight and easy to install as well. So since our presentation is so short, I thought I'd come up with a little intermission jingle right here. If you're in the mood for some piping today, let this presentation be your entree. Thank you, everybody.
Okay, ABS piping versus PVC piping. Some of the main differences is ABS is more flexible and light, whereas PVC is more strong and rigid than ABS piping. ABS piping is always black, whereas PVC piping is always white. ABS piping is also less durable than PVC, where it's more stronger and rigid than ABS piping.
So next I want to talk about different pipe fittings for ABS. So there are many different types of pipe fittings, most of them being used for different outputs or different angles you need to have your pipes go at. So as you can see on the left, we have one to like a simple angle to like, you can have one going up and then having go to the right. So the one on the right side is like a three-way split. You can have different pipes like cut off by like a cap, if you can see in our top right. And you can have water or whatever liquid you're using splitting off into those two directions. They're very useful and can be connected to other types of material pipes like stainless steel or steel piping.
Okay, advantages and disadvantages of ABS piping. Some of the main advantages of ABS piping is that it's very flexible, lightweight, does not rust, corrode, or collect water, and is easy to assemble. It is also very cheap than other counterparts. ABS, some of the disadvantages of ABS piping is it's less durable and undergoes photodegradation when exposed to light.
So 5 things you'll need to know about ABS piping. You'll need to know what ABS piping is in the first place. You need to know that it is used to transfer liquids or sewage and is mostly used underground. You need to know some of the differences between ABS and PVC piping, how ABS might be a little bit weaker while PVC is more rigid and strong. You need to know different types of ABS pipe fittings, how they can be used on different angles and be used to go different ways. And then you also need to know advantages and disadvantages.
So, in conclusion, ABS piping is mainly used for plumbing, sewers, and protecting electrical wires. ABS is less rigid and more flexible than PVC. ABS has many different fittings and can also be attached to stainless steel and other steels pipes. And ABS has advantages is that it's light and easy to use, and disadvantages is that it's less rigid and is susceptible to photodegradation in the sun. So thank you for watching. These are our sources.
Thanks, guys.
Okay, thanks, guys. All right, so no Jesse. So that means that we are going to move down to Brady and Brandon. You guys are next.
Okay. My name is Brandon Telkamp, and I'm here with Brady Reynolds. And today we're talking about concrete piping for Mr. Ward, Mr. Ward's DR180 class.
Purpose of concrete piping. The purpose of concrete piping is to move drainage from one place to another.
Okay, some common sizes of concrete pipe. So there's four main ways that piping is sized. The inner diameter, the overall length of the pipe, and the wall thickness, and the weight per foot of the concrete pipe. There's also two other sizes, which is joint depth and outside diameter, the bell outside diameter. Here on the bottom left, you can see this is the joint, and on the bottom right here is the bell. And there's also, opposed to just circular concrete pipe, there's also an ellipse shaped and a rectangular shaped pipes.
Reinforced concrete is when they take steel cages, basically, like circular or whatever the pipe shape is. It's a steel cage, and they put it within the concrete, and it reinforces it. And they last up to like 100 years or more.
Okay, connections used for concrete piping. So the most common way to hold the concrete pipe together would be using an O-ring, which goes onto the joint, and then the bell housing goes over that, creating a watertight seal. There's also mortar, flexible joint sealants, which is the picture in the bottom middle, and external sealing bands, which is the picture on the right.
When they put concrete, like putting them together, they basically dig a trench, then they clean the pipes off, lift them down into the trench with a crane, and then they line them up with a laser, and then put them together.
Okay, in conclusion, concrete piping is used for moving water and other liquids from one place to another. It comes in many different sizes and shapes, like circular and rectangular. It can be reinforced with concrete. The concrete can be reinforced with a steel cage inside. The concrete piping can be connected using various methods, and they are placed one by one in a trench. And these are our sources.
Okay, thank you. All right, so let's move down to Cole. You're next on our list.
All right, let me just. Is it working?
Yes, we can see you.
Assume it is. Okay. All right, so this is Copper Pipes by Cole Herring in DR180, Mr. Ward's. And a quick overview of what this presentation has is why are copper pipes used, the different types of copper pipes, their fittings, and the advantages and disadvantages of using them. So the reason why copper pipes are used is because they're corrosion resistant to neutral pH water, so they won't erode over time if the water is in a neutral area of pH. They have antibacterial properties, which prevent slime buildup and bacteria buildup. And they're also malleable and easy to work with because you can bend them a lot easier or something. There are these types of copper pipes. You have type K pipes, which are the thickest diameter of copper pipes. And there's a picture down in the bottom right here where it shows it and how the type K is the thickest. The type L is the most common, and it also is in between the type K and M. And the type M is the thinnest type. and you typically see type K as the main water line in like a house. Type L would be the water pipe that would go to a faucet or something, and type M is used where you need a little bend or something. And DWV pipes were used in older homes, and they tend to have around the same thickness of a type M. And then there are two ways that a copper pipe can be used, where it's soft and malleable and you can bend it as shown in this picture. It's popular in refrigeration because you don't have to use as many fittings to get it to work, but it's also more expensive than hard pipes because you have to anneal it and there's a whole process it has to go through. Hard pipes are not malleable and require fittings, but they can be annealed into soft copper pipes, and they're popular in water lines. There are some copper pipe fittings, and you have elbow fittings, which take the hard copper pipes and can shift it in any direction from 90 to 45. There are T, Ys, and cross fittings, which on this picture here, where my mouse is, this is a cross fitting. And a cross fitting is defined as having one input and 3 outputs. A T and Y can be described with this one right here where my mouse is, where you have 1 input or 2 inputs and 1 output. Coupling and unions are almost the same as compression, but the way that couplings and unions work is that they take the pipe and you stick them in this where my mouse is. You take the 2 pipes, stick them together, and that's how you get them to connect. Compression fittings work a little bit differently, where you take the fitting, you put it on one end of the pipe, and there's a little nut that goes on the inside, and you screw it in, and it compresses the pipe and the fitting together and forms a seal. Right here where my mouse is. And then we have caps and plugs, and the difference between caps and plugs is that caps go on the outside of a copper pipe, blocking it off and forming a dead end, and plugs go on the inside of the copper pipe, which form a dead end. So they both form a dead end, it's just how they do it. And valves are where there's a switch that you can use to turn on and off the water flow or whatever flow is in the copper pipe. The advantages and disadvantages of using a copper pipe is that advantages are that they have a high resistance to chlorine, they're non-corrosive and neutral pH water, they have a long life expectancy of 50 to 70 plus years, they're resistant to bacteria growth, and if you're using type K pipes, they can be used outdoors. The disadvantages of using a copper pipe is that it costs more than plastic pipes, it can burst if it's frozen, and leaks can develop in corrosive water, very acidic or very basic water, and it's harder to install and requires more fittings over plastic. The conclusion and takeaway is that copper pipes can be hard or soft. They're used in refrigeration and water lines, various fittings for different needs. They have a long life expectancy, and they're not very good in extreme conditions. Here are my works I did. And that's it.
Okay, thank you. All right, Meg, you're next up.
All right.
It's kind of hard to hear you, Meg.
Oh my God. There. Sorry. This is so bad. Can you hear me or no?
Yes, we can.
All right. So I'm going to be talking about cast iron piping. I'm Megan Lowry. This is DR180, and the instructor is Mr. Ward. An overview of what I'm going to be talking about is the different types of cast iron threads, advantages and disadvantages of cast iron piping, types of fittings, why cast iron pipes are used so little today, and uses of cast iron pipes. Cast iron pipe fittings. Cast iron pipe fittings are commonly used for soil pipes. They are classified as hub, spigot, no hub, or hubless. Hub couplings comprise of a ribbed steel sleeve, which is tightened and held in position by a steel band that clamps onto both sides, lined with a rubber gasket. Cast iron couplings are designed to connect pipe to pipe as well as pipe to fitting. Types of fittings continued. Pipes made of no hub cast are never threaded or welded. These pipes are connected by no hub couplings. Hub and spigot pipe fittings come in two classes of thickness, service and extra heavy. Hubless cast iron fittings are manufactured without a hub. Hubless cast iron couplings are used for joining fittings like L's, Y's, and T's with the pipe. Cast iron threads. Typically, cast iron pipes aren't connected using threads. The threads have to be formed in the cast iron. When using a thread to connect the pipes to each other, a common fitting would be a no hub coupling. You'd put the rubber part of the coupling onto the pipe and fold it down, and then you connect the two pipes. Then you would take the threaded part of the coupling and onto the rubber part and take a 5/16 bit or a different size and tighten it. Here's an example of what it usually look like. So some uses of cast iron pipes is that they're used to transport water, there's storm drainage, sewers, and garbage disposal. Pros and cons. The pros are they're environmental friendly, they're quiet so you won't hear the water running through your house. They have a long lifespan if you take care of them. They're strong and they're heat resistant. Cons is that they're expensive, heavy, harder to install, they rust and corrode. Like, this is what will happen, and it's common in older houses. Why cast iron pipe is used so little today? Like I said, corrosion, which is stuff will build up in them, they leak, cracks, and infestations. 5 things to know is cast iron is not usually connected using threads. Cast iron is used in sewer pipes and garbage disposal. It's quiet. It will hold up for a long time if given proper care, but it will corrode after a while, which is common in old houses that have cast iron pipe. Conclusion is that the 4 common types of fittings for cast iron include hubless, no hub, and spigot. Cast iron is usually more heavy, expensive, and harder to install. Cast iron pipe fittings will be commonly used for soil pipes. And here's my works cited. Alright.
Okay, Meg. Now we're moving on to Anthony and Abby. You guys are up.
So, for how PVC piping, you normally don't see it in the way that it's normally intended to be used, but today we're going to talk about how it is supposed to be used and its intended uses. This is our presentation on PVC piping for DR 180. Our teacher's Mr. Ward, and I'm Anthony Malinowski.
So the overview of our presentation. Today we'll be going over the typical uses of PVC, the advantages and disadvantages, the difference between CPVC versus PVC, pipe sizings, common connections, construction methods, and then 5 things to remember. So to start off with the description, what is PVC? PVC stands for polyvinyl chloride, which is a widely used thermoplastic, and about 40 million tons are produced each year.
So, PVC piping is typically used for sewage use, so sewage goes inside and is transported. It can be used for indoor plumbing, irrigation, or vent lines. The top picture shows how it can be used in irrigation and for how the piping can help water the soil and plants in the area. And the bottom picture shows how PVC piping can be used in indoor plumbing.
Some of the advantages of PVC. PVC is lightweight, it cannot rust, it's flexible. The smoother wall surfaces decrease friction. It is available in longer lengths than other piping, and it's very hard to ignite.
So the major disadvantages is the temperature of what is inside of the pipe. So the picture on the left depicts a PVC pipe that has had hot water running through it for around 8 to 10 minutes. You can see for how the pipe is no longer straight and has warped slightly. That is what you do not want to happen when you use PVC pipes. So if hot water is being transported, PVC piping is normally not the way or the pipe that is chosen. There are also some sizing limitations because the pipes are normally smaller. It's sometimes difficult to find larger sizes. And since PVC is a plastic, it can emit toxic fumes if it is melted or burned.
CPVC versus PVC. The main difference between CPVC and PVC is the temperature range. CPVC can withstand temperatures up to 200 degrees Fahrenheit, where PVC tops out at 140 degrees. CPVC is available in nominal pipe sizes and copper tube sizes, sustainable for commercial applications, and preferred for the transportation of hot water. PVC is only available in nominal pipe sizes, more suitable for residential and recreational use, and better for transportation of cold water.
So there are two major types of PVC piping for sizes. They are called Schedule 40 and Schedule 80. I'm not quite sure if you can see the charts, but the OD, which means outside diameter, and ID, which is inside diameter, are majorly different when comparing them to each other. So if you look at the 1/2 inch for Schedule 40, the outer diameter is the same as a Schedule 80, but the inside diameter is where it's different. So Schedule 40 normally has thinner walls, so it is less durable than the Schedule 80, but it has its own advantages, such as it can transport more at the same time compared to Schedule 80 due to the inner diameter being larger. So there are some common connection types between PVC pipes. The first major type is T's, where it is just simply in a T shape connecting 3 different pipes together at the ends. Elbows connect 2 pipes on an angle, where it can be almost any angle that is reasonable. So you can't have like one that goes back on itself unless if you have a different connection type. Crosses just connects 4 types, so it is an X shape or a plus shape. You can connect PVC piping using couplings or unions, and caps and plugs just seals off one end if you do not want to connect a pipe on that end. So these are some pictures of the common connection types as I described them.
Five things to remember. Some things to remember are the typical uses of PVC, such as plumbing and use in irrigation, the common connection types, the differences between the PVC sizing schedules, the differences between CPVC and PVC, and the pros and cons of PVC piping.
So to wrap this up, PVC piping is fairly cheap and cannot rust. So those are the major two reasons why people may choose PVC piping. It is fairly versatile when you look at the connections. So it can be used in a lot of different ways through its connections. You want to avoid PVC piping when you are using hot water, or else the pipe may bend or warp. And before you buy PVC pipes, you want to know what schedule size you need, so you don't get a pipe that is maybe too thin for the outer walls. And these are our sources.
Okay, that brings us up to Evan and Nick.
Can you hear me?
Yes, we can.
Okay. This is Rubber Tubing by Evan Pori and Nicholas Rust with class DR180 with instructor Mr. Ward. Overview of rubber tubing. This presentation will discuss the specific kinds of rubber tubing and the many ways they are used. Typical uses of tubing. Rubber tubing is used for a variety of hydraulic, pneumatic, process, and medical applications. Fluids or gases are most common for these types of tubes. Rubber tubing is most flexible and very resilient due to its natural or synthetic rubber construction. Often used for in-house piping, plumbing, drain, waste, vent piping, house to main, repairs, cut-ins, and etc.
Rubber pipe couplings. It's a flexible rubber that's used to connect two pieces of pipe together. These pipes are resistant to chemicals, UV rays, and fungus growth. The pipes are compatible with cast iron, copper, and lead, and are most commonly used in engines.
Assembly methods. First, you loosen the steel clamps and insert the pipe into the couplings. Then you tighten the clamps with at least 60 inch-pounds of torque. Then you make sure before you're finished, you give a pipe a pressure test for any leaks or cracks in the pipe.
This is a diagram of the sizes for pipes and for rubber tubing, and factors such as pressure rating, the weight, the length, the straight hose or coil hose, compatibility will determine the size of the hose.
Rubber pipe hose. The hose, you may all know, is a long, flexible rubber tube, and its purpose is to carry fluids from one location to another. A hose can also be considered a pipe.
Its design depends on the combination of its application and its performance, and also affects the size of a hose. The hose can be any shape or size, and the hose is usually cylindrical, so materials can easily pass through.
Connections. You usually insert a hose with a clamp to hold it down, or use a hose cap to twist onto another thread to keep it tight. A common example is usually a garden hose.
Rubber pipe reducers. The rubber pipe reduces the bore of a pipe or inner diameter to a smaller one. It allows for a change in pipe size to either meet system hydraulic flow requirements or to adapt to a different size of already existing pipe.
Assembly methods. When fitting an eccentric reducer, the top or flat part must be horizontal to the top of the pipe to avoid development of an air pocket. For both eccentric and concentric reducers, the direction of the increasing angle is determined by how the fluid must be regulated.
Sizes. The length of reduction is equal to the average of the two pipe diameters or bores. The concentric reducers are standard reducers with symmetrical form. They join two different diameter pipes or tubes along the same center line or axis. And eccentric reducers, they're asymmetrical in form and they're used when a uniform pipe level is required.
Pros and cons. Pros, it's oil resistance, abrasion resistant, heat resistant, strong adhesion, and the cons are that it's not resilient to low temperature, it has a bad ozone resistance, low insulation, and low elasticity.
The conclusion. What you should take away from this presentation is the connections used for rubber piping, an understanding of the rubber pipe hoses, what rubber pipe couplings are, and a basic understanding of rubber pipe reducers, as well as the sizes or determination of sizes for each.
And this is our works cited.
Okay, thank you. That brings us to Josh and Kuiper.
Okay, I'm gonna share my screen.
2 more presentations. Does anybody know where the charger is?
Are you ready, Josh?
Yeah.
Okay, so we're doing galvanized piping. This is class DR 180. Our instructor is Mr. Ward. I'm Kuiper Bell.
And I'm Josh Mayo.
Oh, shoot. What the heck? All right, so what we'll be talking about is fittings, the purpose of a galvanized pipe, how long it will last, pipe sizes, how to put it together, and the disadvantages of a galvanized pipe.
For pipe fittings, there are various pipe fittings, so they could be able to go in different directions and they'd be able to connect together. And this would allow pipes to go in different directions and they would be able to move water faster. Right.
So the purpose of a galvanized pipe is durability against rust and corrosion. That's like the main reason people use them. The zinc coating prevents mass amount of corrosion and allows it to not rust. This allows it to last much longer in pipes and can be used in like outdoor situations, I guess, and like underwater and that stuff too. It can some other purposes, like not necessarily for water, but like they can just be used. Some people just use them as like shelves and racks and stuff like this.
The galvanized.
So, how long should a galvanized pipe last? Galvanized pipes, assuming that you just bought them and installed them, they should usually last between 40 and 50 years. Again, this is because the zinc protects it from corrosion and allows it to last very long compared to other pipes because it doesn't corrode or rust.
For pipe sizing, there should be fraction numbers you look at a chart and the higher fraction number it has in the front, the bigger the thickness and diameter would be, and that's how you would find pipe sizing.
Okay, so how you put together a galvanized pipe? It's pretty simple. There's threads on one of them, and internal or external threads on one of them, and internal threads on the other. Or you could like use a joint. But you put it together, and then on the one with external threads, you would use you put the Teflon tape around it, and then you would screw it in essentially with your hands, and then you'd put it in a secure area wherever your water needs to go.
when you're using a galvanized pipe, you should watch out for blockage, corrosion, or bacteria because those all could damage the pipe and make it in worse condition.
In conclusion, you should know that fittings are used to connect and combine pipes. Galvanized pipes reduce rust and corrosion. Galvanized pipes last 40, 50 years. Galvanized pipes have many different sizing. You can put them together using threads and Teflon tape. Bacteria can form in the pipe, and there could also be blockage. There's our works cited.
Okay, thank you. All right, so that brings us down finally to Maynard and David.
Are we good to go?
Yeah, whenever you're ready, we're ready.
Hey, Maynard. Knock, knock. Maynard? Maynard. Knock, knock.
Maynard, we can't hear you. Hello, Maynard.
Maynard said he's going to leave the meeting and rejoin.
Okay, we'll wait for him.
Hello, can you hear me?
Yep.
We can hear you, man.
All right, that was. All right. Okay. All right.
Hey, Maynard.
Yes.
Knock, knock.
Who's there?
Oranges.
Oranges who?
Aren't you glad I didn't say steel pipes?
All
Welcome to our
right.
presentation.
Our presentation on steel pipes by David Tyler and Aaron Sturb. The class is DR 180 for instructor. So a quick overview. Steel pipes are any pipes consisting of a steel alloy. They are still used today, and we will go over. We'll also cover their advantages and disadvantages, and we will also cover the assembly sizing process and the connection type. So the uses of this pipe, they were once commonly used to carry water and other flammable gases, and they're still used to carry gases such as propane and other natural gases. They are also used on fire sprinklers due to their heat resistance. Fire breaks out, and commercial buildings typically use these pipes for heated water transfer.
So some advantages of steel piping would be that it is stronger than aluminum. It is easier to weld than aluminum. There is a lot of versatility as opposed to carbon steel pipes. The weldability is, again, as I said, greater than aluminum, and they're very easy to weld. There's a lack of chemical reactivity, so they won't react with other steel pipes or different elements. And there's a high speed erosion resistance. So if there is liquid going through the pipe very quickly, it won't erode, because that's just something that comes with steel pipes. And they are very sanitary. So some disadvantages would be the weight of the steel pipes, the cost, the corrosion resistance to chlorides is not very good at all. Type 304 is a type of steel pipe. It's the most common, and it's not usable between 1800 and 1640 degrees Fahrenheit. It also has a low mechanical strength.
Now on to connection. They are connected typically with tapered threads, and they are screwed on with the use of a pipe. This thing. Then sealant and tape create a stronger bond. And when pipes are used for non-domestic purposes, they are joined by TIG welding. And pipes are assembled by the use of centrifugal casting. Now, basically, what centrifugal casting is the spinning centrifuge, and then the alloy or any material that you're using to make the pipe out of placed inside, and then it's around to coat the inside. And then the centrifuge can be sized for whatever type of pipe you need to use. Metal cools off, take it out.
How the pipe is sized. So pipes are measured and sized by the inner diameter, because a lot of times pipes are used for transporting liquids, as opposed to tube, which would be measured by the outer diameter. And tube is mainly used for structures. So some 5 things that you guys need to remember. First thing is that type 304 is the most common. Second thing are that they are usable for sanitary purposes in hospitals and such. Third is that stainless steel pipes are a chromium steel alloy. Fourth, they are resistant to corrosion and erosion, corrosion being chemical and erosion being physical. Fifth is that they have a low mechanical strength.
You are getting hype.
About buying some pipes.
To remember the type.
Stainless steel.
Thank you for watching the presentation.
All right, thank you, fellas. All right, so now I want to talk to you a little bit about our exam review. There is no exam review online because we don't want you just to print it off and copy it. So this is going to be totally up to you to write things down and commit those things to memory. If you go back to Blackboard, you're going to see it looks a little bit differently because we've taken some things down. But nevertheless, bring up my Blackboard here. We will go over what is going to be on the exam. All right, so the things that you are going to have to know. Things we learned back in EG 110, as well as DR 180, and that's how to identify a thread call out. There will be a section on the test. Nope, I'm trying to see where you guys are. There we go. There will be a section on the test where you're going to have to identify threads. So I will have a thread labeled. For example, it might be quarter 20. You know what? I'm going to change cameras here so I can write and you can see my camera here. And I'm going to stop recording. I'm going to stop the Zoom recording now so that we can, you know, I'm just going to keep it going. So let me change cameras here. Yep. Now you're over on the other side. And this way I can open up my other document camera. That's a beautiful face right there. All right, so some things that you are going to see as soon as I share this with you. So I'm going to share my visualizer. Here we go. So you are all looking at my my screen, my camera, correct?
Correct.
Yep.
Yes.
Can you all hear my daughter screaming below me?
A little.
Just slightly.
I had to stomp on the floor so she knew we were up here. What the heck? Where's my focus? There we go. All right, so you're going to see something on the test that I'm sticking with my quarter 20. So we're going to see something that's going to look like this: quarter 20 UNC 2B. What does the quarter stand for? This is where you guys are going to want to unmute and be able to interact with me.
The length of
Isn't that the major
screw?
diameter?
Yeah, the quarter is going to be what? Now you got to tell me again.
The major diameter of the screw?
It's going to be the major diameter. So the major diameter of the bolt. So what's the 20? So that's going to be our major diameter. What's the 20 going to represent then?
Isn't the
Threads per
20
inch?
how many threads per inch?
Yeah, that's going to be, that's the pitch. Threads per inch. What's the UNC stand for?
Unified National Course, so it's a coarser screw or a coarser thread.
It is UNC does stand for Unified National Course. That is true. But what is that? What we're trying to relate, what is this? Not just the UNC, because it could be UNF, right? UNEF. So what are we looking for in this location? What are we talking about? Anyone? Crickets? So, Abby, was that you? Did you say series of thread?
Yeah.
Yeah. How? Yeah, the thread form. Okay, so this is the thread form. Because remember, it could be a coarse thread, could be a fine thread, could be an acme thread, could be a square thread, could be a tapered thread, could be a pipe thread. So it's just not, you just aren't reading off what the thread type is listed. We need to know that this is the major diameter, this is the pitch, this is the thread form. Then what does the 2 stand for? We're looking just at the 2. What is the 2? Don't everybody jump at once.
Isn't that the class of fit?
That is the class of fit. Remember, there's a class 1, class 2, class 3, how tight the tolerances are going to be. So we're talking a class 2 is the standard type. So this is going to be the class of fit. And then what does the B or A, what does that tell us? Because it could be B or it could be A. What does that tell us?
If it's right or left-handed, like
Negative.
screw in.
No, that's not true.
Is it external or internal?
It's what?
Is it external or internal by B being
Yes, it
internal?
tells us whether it's an external or internal. And remember that this is only true for me. I'm the only one who says this, is that B equals bottom, A equals around. So A is going to be external, and B is going to be internal. We also are going to have to be able to identify the types of holes. So remember, we may have a hole, and I'm just sketching these out here. We can have a hole that looks like this. Right? What kind of hole is this?
That's a drill hole.
That's a drill hole, right? That is a drill. Okay, we have another hole. And that hole looks something like that. What is that one?
That's a reamer.
That's a reamer. How about this hole? What type of hole is that?
Would that be a tap?
That'd be a tapped hole, yes. And then how about a hole that looks How about that?
That would be chamfered hole.
That is a chamfer hole, yes.
On my video, I look like a ghost.
Okay, hold on, everybody. I need to assist my wife here for a second. Resume recording. All right, so then we have yet another hole that's going to look like this. And that's going to have a cutter that looks something like that. What is it? Meg, is that you? Counterbore, yes.
Counterbore.
So we have a counterbore. And then we have one more. How about that one?
That'd be countersink.
Countersunk, yep. That's a countersink or a countersunk hole. So you will need to be able to identify each one of these cutters and the style of hole that they are going to create. Okay, as far as welding, you're going to have to be able to identify the difference between stick, MIG, and TIG. You're going to have to be able to identify the 5 basic joints. What's this joint right here?
A
butt joint.
Butt joint. How about this joint?
Corner?
A corner.
Corner joint. Yep. And then we have
Edge.
edge joint. Yep. How about that?
Lap joint.
That's a lap joint. Yep. And then our final joint.
Is that a T joint?
That is a T joint. Yes. Okay, so then there's also, that's our how we're going to set up. Now we have to have some types of grooves. What type of groove are we talking about there? So this is a type of weld groove.
J groove?
U.
This is a U groove. Yep. That's a U groove. How about this guy?
A V.
V groove. Yep. I'm making it tricky. I'm drawing them upside down. How about this one?
Is that a flare, I think?
It's a flare V, yep. And then how about this guy?
J groove.
J groove. Good. Okay, you'll need to be able to have to identify a weld symbol. What does it mean when the symbol is on the top half? What's it mean when the symbol is up here?
It's on the opposite side of the where the arrow is.
Yep. So, giving you an example. Yep. So this would mean that it is on this side. Okay. What would that first number? What would that stand for?
The height of the groove?
Well, we can just call that the size of the weld size. And the symbol is the, what's the next thing?
Type of groove.
The type. And then we might have something that looks like this. What does the 1 stand for?
Leg length.
That's how long it is.
From center to center.
Yep, and this would be this center to center. I'm just typing C to C, saying center to center, so we know how long they're going to be staggered. Okay, and what typically goes in the little flag area?
Extra information.
Not
So
extra
the type of
information.
weld that you're doing.
The process. Weld process. Okay, what if we have this little flag here? What does this guy mean?
In the field.
weld.
Weld it in the field. And then what does this guy right here mean?
All around.
All around.
All the way around it. Good. Okay, and then, of course, you're going to want to know the different types of pipes that we just covered today. So you may want to go back to the presentation. You're going to need to know what a rubber, steel, copper, PEX, ABS, concrete, PVC, cast iron, and galvanized. You're going to want to know what those are. You're going to want to know the common types. I can tell you there's going to be a matching on that section. So I'm going to have a description of what rubber piping is, and then you're going to have to match that description of what rubber piping is to what it actually is. Okay, you're also going to need to know the manufacturing process. You're going to need to know what compound dyes are. You're going to need to know what combination dyes are. We want to talk about the extrusion process. What in ferrous and non-ferrous metals are. We want to have, or we're going to look at what casting is, what steel alloys are, as far as the machine process. What are lathes, grinders, drill presses, CNC machines, a horizontal mill, a vertical mill, and a shaper. Again, you're going to have to take those pieces of equipment. That, again, will be a matching, where you're going to have to take the description of that piece of equipment and match that to the name of what that piece of equipment is and how it works. Now, the final exam is not difficult. Most people take within 45 minutes to an hour. I already have that set to open tomorrow at 8 o'clock a.m., so you can start that. But the last thing that I want to discuss before we leave is your final papers that are due. So I've had some questions on those. Remember your final papers. I'm just looking for things that I have on my desk here. If I was going to say, how am I going to make this controller? Boy, there's going to be a lot of parts to that, and there's a lot of work that's going to go into that. As opposed to maybe taking my pen, and saying, okay, there's a cap here. It can be a disassembled how can I get that? And again, you don't have to have any of these things in your hand. They're just things that you're going to pull offline. And what I want in those descriptions, again, is how is it made? You don't have to go into specifics and tell me everything. If I would use, I use the truck, for example, the skateboard truck. I know that that is going through a casting process, aluminum casting. I know that the threads have to be thread and turned. So I'm going to talk about the material it's going to be made of, how it's going to be used for the truck, and then of course there's the wheels that go on it, and those are going to be a compressed thermoform wheel. So the process that's going to go into them, whether they're going to be turned down and so on. So I'm looking for those papers. Remember that I'm looking for, and you still have open in Blackboard. And I think I'll share my screen with you so you can see this, just to make sure everyone's on the same page. So some of you have already sent this or filled this stuff out, or not filled it out, but actually submitted it. So make sure that you have your sheet metal nesting submitted. You have your fidget spinner that you're going to have submitted, your piping presentations you did today, and then your final project, your final paper that you are going to write. And then tomorrow morning at 8 o'clock, your final project will pop up. So things look a little bit differently again on Blackboard. But that's so that you can finish up what you need here. Hopefully you took some notes with what we were covering on the final exam, because you'll need that. But other than that, that's all that I have for our exam review and for our final presentations. I thought the presentations went really well. Again, today, I think it's a little bit easier to present from your own home than it is to stand up in front of people who can actually see you. So I know you guys started school for most of you this week again, going back to high school. We look forward to finishing up the semester and then seeing you guys again in the fall, because I know that I will be teaching. You guys have DR 240 Advanced SolidWorks, which I know I'm going to teach for you. And then I believe that you also have DR 229. I think that I'm also teaching for you. Not sure on that one though. So I'll see you guys again in the fall. Good luck on your final exams. Make sure you get everything submitted. All of your coursework, the piping, the fidget spinner, the sheet metal nesting, the final project are all due by Sunday at midnight. And then your exam is open tomorrow. Remember, your final exam must be completed by, I'm looking up the date because I don't remember. Does anybody else remember?
Next Tuesday, I'm pretty sure.
I think you're right. I'm just double checking on my calendar. Next Tuesday. So next Tuesday by midnight, on the 28th, your final exam is due. So tomorrow morning, when the final exam opens, it tells you, it actually says on there that it's open, and it's open until, and it has on there the time for it to be finished. All right? Any questions, comments, concerns, worries, wonders?
I have a question.
Go ahead, Meg.
So about the paper, we have to talk about like each part of whatever we're talking about individually, or like the whole thing in general?
Well, we don't want to talk about the whole part in general. You don't have to get so detailed that you're going through and spending, hours and hours. The average paper runs about 1 to 2 pages, when you're trying to describe what it is that has to happen. So remember, we're talking about what's the machining process, what's the material, are there any weldments involved, that sort of thing. So that's what we're trying to figure out for your final papers, making sure that we have all the things that we've covered today. Now, some of you may or may not have piping involved with your project, depending on what you decided to use for your your final assignment.
The only reason I'm asking is because I'm doing a car wheel.
Well, if you're dealing with a car wheel, then then you have, of course, the rim, and then you're going to have the wheel, the rubber wheel that's going to go around it, right?
Yeah.
So there's a lot of machine process that goes into making that rim. So we're gonna talk about the rim and the rubber tire.
Okay, so like those two, I should probably.
Yep. Okay. Any other questions? All right. If you guys have no other questions, that's all that I have for you today. You guys did a fantastic job this semester. Let's finish up in the final 3-4 days of class and move on into summer and get ready for next year. All right.
Thank you.
All right. We'll see you guys. Take care.
You too.
See ya.
Bye.
Bye.
Thank you.